Hi, I'm Dr. K.Nevelsteen. Let's say there's two systems that we want to be interoperable. So we have a system here with a triangle representation and say, for example, here with a diamond representation. One option that is possible is that the internal representation is translated from, say, for example, from the triangle to the diamond, and then these two can communicate. The other possibility is that we have the diamond representation and we have the triangle representation, and the internal representation is translated both to a new protocol, say for example a square, and then these two can communicate. We have to remember though that these translations are expensive and difficult, and also that by changing the internal representation, that the systems have to be taken down every time the protocol changes between the two systems. And since the metaverse doesn't exist yet, then it's hard to know a priori what features will be needed. So it could be that there's many updates and lots of downtime. So let's try a different approach. So if we have our our triangle representation and our diamond representation, what we're going to do is we're going to ask these worlds to first expose their APIs. Exposing the API does not require an internal translation, so that means that this is usually straightforward and at low cost. So then what we're going to do is we're going to have a translation externally to the system being integrated. So we're going to have the same translation from the triangle to the diamond here. And then these two can communicate. And then also in the scenario where there's a common protocol, we ask both systems to expose their API. We have a translation from the triangle to a new protocol, which is a square, and a translation from the diamond to the new protocol square, and they can communicate. But also here, these translations still remain really expensive. But at least the translations are external to the systems, which means that the systems don't have to be brought down every time that there's an update to the protocols or the schema. But we can do better than this. So the gain of doing external translations is not so apparent when you're trying to integrate two worlds, but the gain becomes more apparent when you're trying to integrate four. So let's say we have four different worlds that we're going to integrate. We have the triangle representation, we have the diamond representation, we have the circle representation, and the star representation. To get a fully integrated graph, that would mean that n times n minus 1 over 2 integrations. For four participants, that would be 6 total integrations to get a fully integrated graph. 1, 2, 3, 4, 5, 6. What we're going to do is we're going to ask first that the worlds export their internal representations into an API. So now the interfaces and the parameters of those interfaces inform the common protocol that can be used for the worlds to speak to each other. Let's say that the triangle and the diamond representation, that they have a representation that is very similar to each other, which means that it would be a lower effort for them to translate their schemas to each other. Then we would have a translation from the triangle to a new protocol, which is a square, and from the diamond to the same square protocol, and then those two worlds can communicate. That means this integration has already been done. Now, for the third world, say it's not so easy for the circle representation to be translated to the square, so it can choose either to change its representation from the circle to either the triangle or the diamond. So we could have a external translation from the circle to, say, for example, the triangle, and then the third world could communicate with the other two. That means this integration is complete, and also this one. And then we have the last world. The last world can also choose out of the protocols which translation is the easiest. Say, for example, it's very different, and the closest representation to its protocol is, for example, say the circle. Then we could have a translation from the star to the circle, and then we would have a fully connected graph with 1, 2, 3, 4 different integrations. There's obviously room for improvement in this diagram. Let's say that the diamond has decided to change its internal representation to that of the square. So this translation is no longer needed, and it is now a square represented world. Also, that someone says, well, the number of hops for the star to communicate with the square is way too many hops, because that would be just 1, 2, 3 hops. So we want to reduce that number. So someone comes along and says, well, I'm going to build a translation from the star to the triangle representation, or, for example, from the star to the square representation. And then this translation would no longer be needed. Note that these translations can be added or removed from the ecosystem without any downtime from the systems being integrated. But let's say that instead of the star conforming, let's say that a new protocol is developed. And this protocol encompasses the commonalities of all the worlds except for the square world. And let's say that the circle represented world has decided to change its representation from the circle to this new protocol, which is a heart. These translations are no longer valid. So then we have to have a translation from the star to the new heart protocol, and also the translation from the triangle to the new heart protocol. So now you can see that we have an ecosystem that successfully supports 2 possibly conflicting standards. Again, since the metaverse doesn't exist yet, it's hard to know a priori what features will be needed, meaning that updates and iterations to the protocols will likely be frequent, and such a system is advantageous. Thank you for watching.